Okay, so now we're looking at data types, and we're going to get into something pretty cool that's, very critical, allows your game to start to become a little more complex and interesting. So the data types we've seen so far, we have things that are numbers, right? Number values. We also have data types that are strings and images, right? So let's take a look. Here's some examples of some functions. And think about what they're going to evaluate to. What kind of data type is this going to return? Right? And it says if you're not sure, we can type it in and try it out. So let's go ahead and try that out real quick. Let me get a, let's see, I've got this over here. I can just put in, let me make this a little bit bigger. I think I can do that like this. Let's move that over for a second. And if I just did the first one, I think it was plus 1, 4, right? And that returned a number value, right? 5, right? That was the data type. Okay. The next one is divide for 2. And I know you know this, but I'm going to do it anyway. Divide for 2. It's going to return a number, exactly. And then, circle 10, solid blue. Okay. Here we go. Circle 10, solid, oops, that's a string, solid, and blue. That returns a small little blue circle. Okay, last one here. Less than 3, 4. Less than 3, 4. What's that going to return? Let's try that out. Less than 3, 4. Turn true. So, this is a function, the less than function, which is evaluating these two numbers in its domain, right? And it's evaluating whether or not 3 is less than 4. And it returns something, it just returns a true statement. It doesn't calculate a new value or anything, or produce an image or a string or anything. It just tests. It's like a testing, logical, like little test that says, hey, is this thing true or false? And that's a brand new data type for us. Numbers, strings, images, those are 3 data types, but now this data type is called a Boolean. It's called a Boolean, okay? And let's see, that's the function, right? It tests whether or not the first number is less than the second number, right? So what are some other ones you could think of? Obviously, you have the greater than, and you have the equal. And they all take in 2 numbers as their domain. They all produce a special value called a Boolean as their range. So in your contracts, you should add these in now, right? The less than symbol takes in number, returns Boolean. Greater than symbol function takes in number, returns Boolean. And the equal takes in number, returns Boolean. Okay? It says Booleans are answers to yes or no question. Boolean functions are used to perform tests. In a video game, you might test if a player has walked into a wall if their health is equal to 0. Machine in a doctor's office might use Booleans to test if a patient's heart rate is above or below a certain level. And Boolean values can only be true or false. Okay? Just a logic, true or false. Now, try typing a number into the interactions window and hitting enter. What do you expect to get back? Well, if I just put in a number here, like 55, and hit enter, I get 55 back. Okay? What about a string? Okay? Let's try something. Bootstrap is awesome. Okay, I get the same string. It evaluates to itself. Alright? And the same thing with Booleans, right? Let's try putting in, it says put in false. Okay, we'll try that. Let's go ahead. False. Return false. True. Return true. And so you see, with just like all the other values, Booleans evaluate to themselves. The circle of evaluation can also be used with Booleans. Try converting each of the following math expressions into circles of evaluation, and then converting those circles into code. So you should practice this. I'm going to go ahead and draw a circle. Big circle with a line on the top. At the top, I'm going to put equals. On the left, 10. And on the right, 16.1. And then if I wrote that as code, it would look like this. equals 10, 16.1. Evaluates as false. Those two things aren't equal. So you can do that for each of these, right? You can find, here's the function value, the main function value, and two elements in its domain, which is a number over here and a number over there. Now here I have it, and this is the Boolean. The bigger circle is going to have to be this Boolean here, and then the two numbers I'm going to get are going to be produced by a circle on the left, which is a subtraction, and we're going to find the difference over here for the first number, and then a product of two numbers with multiplication on the right. So you're going to have open parentheses, less than symbol, open parentheses, minus 41, close parentheses, open parentheses, times 92, close parentheses, close parentheses. Okay, you can go ahead and work on that. All right, now there's many other functions that produce Booleans. This is a very useful one right now, which is to be able to compare strings, and we call it string equals huh. So that question mark, you'll hear me say this many times. Instead of saying string equals question mark, I'll just say string equals huh, because huh is kind of what people say when they're asking a question. Huh? Something like that. Anyway, string equals huh, apples and oranges. So what would this return? Well, it's going to evaluate this string, it's going to evaluate that string, it's going to compare them to see if they're equal, and if they're equal, then it comes back true. Otherwise, it's going to come back false. In this case, it'll come back false, right? So if you think about it, this would be very handy, for example, when you're checking a password, right? You want to make sure that the string input as the password is an exact match to the one in the database, okay? Also, whether or not you want to test if the person has hit up or down, we can do a string equals huh to test if they're going up or down or something else, okay? So make sure you have a contract written out for all four. What are the four so far? We have less than, we have greater than, we have equals, and now we have string equals huh. String equals huh is another one, okay? Okay, here we go. Alright, now it says open the cage program. We're going to do a little work here, and you're going to find that cage. Let's see, it's right here. It says cage for Sam the butterfly, okay? And so I'll click and open that up. Alright, here we have it, and if we hit run, see we have Sam. Sam is a butterfly here, and Sam moves around. If you use your arrow keys, you can move Sam to the left. You can move Sam to the right. Okay, you can move Sam up. And you can move Sam down. And of course, not only are you moving Sam around using your arrow keys on your keyboard, but you get to see the coordinates as well. So here he is right in the center of the screen. 320 is halfway to 640, and 240 is halfway to 480, so there's the center. Now the deal with Sam, I'll go back and read the story here, but basically the window is Sam's yard, and it says, Sam is free to walk around the yard. Coordinates at the top of the screen update to tell you his location. But Sam's mother says it's okay for him to step outside of the yard, but only by a short distance. Specifically, she wants to make sure that she can always see at least a little piece of him. Sam is safe as long as some piece of him is on screen. That means he can go a little past 0 on the left-hand side or a little past 640 on the right, but how far can he go? So just looking as I go to the left, still see him there at -40. Oh, can't see him at -50. -40, you can still see him. And over here at 680, can't see him at 690. Okay, you see where I'm looking is right up here at this X coordinate, right? So when he goes to the right from there to 690, so I need him, if he's going to be safe, he has to stay less than 690 and greater than -50. Okay, those are the values that we're going to need to put in to keep him safe. Sorry. Okay. So they want us to go to page 19 in our workbook. Page 19. And here we have it. As long as Sam's X value is greater than -50, he'll be safe on the left. And as long as his x value, you have to write this out, right? Use the same idea here. But now it's going to be less than 690, right? Then he's still safe. As long as he's less than 690, and you would draw this circles of evaluation, which is then going to help you set up for the code that you're going to need. And then you're going to have to go through and start to work on this safe left, huh? Safe left, huh? Is going to take in Sam's x-coordinate, checks to see if he's safe on the left. Right now, in the program, okay, if we look at it, it just returns true. Safe left, huh, takes in x and just returns true. Safe right, huh, takes in x and is right now just returning true. So no matter what happens, it's saying he's always safe no matter what. It takes in his x value, but it's just returning true. Well, that's not good, right? Because what we want to do is we want to modify these so that Sam is only safe when his x position is greater than -50 or less than 690. So we need to test, we need to use the design recipe. You can use the design recipe here to write out the contract and purpose statement, get yourself some examples, and do the definition. Then do the same thing for safe right, huh? Okay? And I'm going to pause for a minute there, and then I'll have that code written up when I get back. Okay, now hopefully if you haven't finished, go do your work and finish up. But by now you should have been able to figure out what you need is you need a function, safe left, huh, which takes in his x position and checks whether or not his x position is greater than -50. You also need a function, safe right, huh, which takes in his x position and checks whether or not his x position is less than 690. Then if you click run, you can test it. So when I go to the left, I'm holding down the left button, but now that he's at -40, it doesn't matter how many times I press left, he can't go to the left anymore. When I go to the right, he can go off the screen. I don't want to get him off the screen. I need to have him limited. So what's going on here? So the problem is all that safe left, huh, and safe right, huh, are doing is they're providing a test, right? So safe left, huh, is returning false or returning true until he gets to -40, and then it would return false, right? Safe right, huh, is returning true until it gets to 690, and then it returns false at that point. But then we have a third function on screen, huh, which is checking whether or not he's safe. And right now he's only safe on the left. He's not safe everywhere. So you see, it's just on screen, huh, is just checking safe left, huh. So now I got to figure out how can I get one function to test two Booleans, right? To check and see, you know, is he safe on the left and safe on the right? Okay, and what you're going to see is that, you know, we have to get into another type of a Boolean here, and that's a Boolean where we check whether or not two things are true or false, right? So here we have a couple of statements here. We're going to think about this, okay? Sugar is sweet, okay? So we'll say that's true. Ice is hot. Okay, we say that one's false. Ice is not hot, right? So now we have to test this. It says sugar is sweet and ice is cold. So how would that evaluate? Well, sugar is sweet and ice is cold. So that would all evaluate to true. This one would evaluate to true too. Sugar is sweet, that's true. Ice is hot, that's false, right? But this one, sugar is sweet and ice is cold. Now that's true. Here we go. Sugar is sweet and ice is hot. That's false. Sugar is sweet, but ice is not hot. And so when it says and, it's wanting me to get true for both of these things. And I'm not going to get true for both of them. So and requires both statements to be true, or requires only one statement to be true. Watch. Sugar is sweet or ice is cold. Okay, so since this is true and this is true, the whole thing evaluates to true. But this last one's where it's going to get different because it says sugar is sweet or ice is hot. All right, well, sugar is sweet is true, ice is hot is false, but I have an or statement. So as long as one of these is true, then it evaluates to true. So sugar is sweet, true. Ice is hot, false, but the or says true because at least sugar is sweet. Okay, so that's what we have to do. We have to use and this should be your contract, right? You need to put a contract in there. It takes in two Booleans and returns a Boolean. And then you have an or, which takes in two Booleans and returns a Boolean. And returns true only if both of the Booleans are true in the input. And or returns true if either happen to be true. Okay? Now they want you to go to page 22 in your workbook. So you're done here. Now you can write a circle of evaluation with an and. So you have and 2 less than 5. That'll be another circle over here. And 0 equal to 6. Okay? So you can practice this out. You have an or. Okay? You can practice that out. Right? Do the circle evaluation and then write the code from it. Then you're ready to go down here and start working on the OnScreen function to get this to work right. Takes in the x coordinate, checks to see if Sam is safe on the left and safe on the right. Okay, so we'll have you go ahead and figure that out. You're going to use the OnScreen and it's going to take in two Booleans, right? Safe left safe right right? So Boolean is going to return a Boolean. And so what is it doing? It's taking in Sam's x position. Actually, that's right. Wait a minute now. It takes in just his x coordinate. It doesn't take in two Booleans. I apologize about that. It just takes in his x coordinate. So this is OnScreen takes in a number, returns a Boolean. And then what does it actually do? Well, it takes that x position, that x value that it takes in the domain, and it checks safe left and safe right checks them both. And then if they're both true, so we have to have an and function so that they're both true, then it will return true, that he's safe and on screen. Okay? So I'll have you, work out some examples in there and get through a definition. And I'm going to pause this again, write up the code, and show you how it should work when you're done. Okay, so now if you've got your AND function for OnScreen working, if you've got OnScreen working well, you can see that you should have them bound on the left and on the right. Okay, and for a little challenge, what should you also need to do? All right, shouldn't we have safe up and safe down and then we would modify OnScreen so that it now checks all four, left, right, up, and down. So I'll leave that for you to figure out how to do it, but you can check here. Here's what I've got for my OnScreen if you want to take a look at that. Okay, so try adding in up and down as well, and that'd be a nice little challenge for you there. Okay? And you can combine them is what it says there. Now, there's a little moment here we should stop and just consider this. If you're going to do OnScreen you could write it to where it just does the safe left function and the safe right function and don't even name the function. And then you have it over here where we're just checking OnScreen and we actually have something for the left and something for the right. We're actually using the functions and taking the time to define the functions. So a lot of people will want to go this way, right? Because if I do this, then why would I won't even have to bother defining what is safe left and what is safe right That was just extra work. I could just write that all into one function. But good programming, right, is all about design. And that's what we're talking about here. There's more to being a writer than good spelling and grammar, right? There's more to being an architect or an artist than just building a bridge or coloring in a canvas. All these disciplines involved an element of design. And the same thing is true with a programmer just writing the code. Okay, you get decent at writing code, now you're able to write sophisticated programs that include multiple functions, and congratulations. But that also means you're ready to consider what it means to design the code that you write. So the reason why you would want to write your code and have a couple different reasons, but have these functions written independently. First one we're getting at is that if you were building a car, you would want to be able to test each component of the car, like the engine and the transmission. You'd want to test each component one at a time, right? Same thing with your code. If it's not working for some reason, you want to be able to check just safe left, just safe right, instead of building a big, huge, complex code that's filled with everything in one function, where it can be very hard to find where is the error. You can write one just to check on the left, just to check on the right, and then stitch them together with OnScreen, That is generally considered a better design so that you can debug. Okay, that's one reason. Another reason, it says, simple functions, to keep them simple, is that it allows programmers to be lazy. So what happens when you have your code is if you just write it everywhere you go, you always write in these big complex functions. Then when you suddenly change to a different size monitor and you want to change the boundary, you only have to go to one place to change the boundary, right? If you're going out to 1,000 pixels, we would only have to change it in one place, and we know exactly where to go. Is it safe on the right, right? It's the only thing we need to change. And we wouldn't be wondering, oh, where else did we leave something like that? So if we write a code that's specific to, just testing the screen size, then whenever we want to make changes in the future, we know exactly where to look to make that change, okay? And you don't have to change it in a bunch of places, you just change it once. Oops. And I know we're getting near the end of this unit here. But I know that yes, that's the very end. Let me double check. Did we miss anything? You can see. No, we didn't quite get through everything here. Here it goes. Okay, so be careful, because even though you make a program that works fine, it could be a badly designed program, because badly designed programs can work just fine. They're just often harder to read, harder to test, and easier to screw up if things change. All right, so as you grow and develop as a programmer, you need to think beyond just making code work. It's not good enough if it works. As artists, we should care about whether or not the code is well designed. This is what functions allow us to do, okay? Everyone from programmers to mathematicians use function to carve up complex problems into simpler pieces to make it possible to design elegant solutions to difficult problems. Okay? Now, boundary detection code we wrote. Safe left, safe right, Very useful for video games. You can stop a character from traveling through a wall, or regenerate the character once it's left the screen. So now you should go to your game file, okay, your blank games over here. Get rid of all this stuff over here. Let me hit run. And close out that guy down there. So now you should have your on-screen right here. Okay? This is making the danger and target come back again. We need to know that they're gone. So now you have to update this part of the code here, right? Is the character visible on the left side of the screen? So you have a safe left, You got to write your example and write it correctly, the code in there for safe left, Then you've got it for safe right, as well. And then you have it for on-screen, Okay, so go ahead and update that, and you're making good progress on your game now, okay? And that is really the end of this lesson here, where you now have, you're using your Booleans to keep to test whether or not your player is on the screen. Okay, good job.